pre-stress and post structures. Both are there. Okay. So pre-stress structure is very important to understand. Okay. So first of all, today I have prepared a video for you. So please ask the others to join. Only 24 are there. Okay. So first of all, I'll just tell you what is the concept. After that, I will show you one video. I'm having a video of pre-stress concrete. I think it will be better for you to understand. Okay. So first of all, I will tell you the concept of it. Okay, try to understand this. This is very, very, very important. You can accept theory questions from this part. Okay, the problems are also very easy, but the theory portion is little bit not tough. I won't tell it is tough because you have studied even tougher than this. Okay, this is one you have studied even tougher topics. Okay, so this is not tough for you now. Okay, so coming to the first new concept, take your mind fresh. Okay, I'm taking you to new concept that is pre-stressed concrete. Okay, so what is happening in a pre-stressed concrete apart from the normal reinforced concrete structures? Okay, so normal reinforced structures, we all know that it will be having reinforcement bars at the bottom. Okay, normal RCC structures, they will be having reinforcement at the bottoms, and when a load is applied to it, what will happen? The beam will bend in this direction. Okay, beam will bend in this direction, and eventually cracks will be developing. And with the passage of time, if the load is more, it will crack. The structure will fail. Okay, so that is reinforced structures. Coming to pre-stressed structures. Okay, we are actually introducing a new concept here, that is pre-stressed concrete. Okay, so what is happening in a pre-stressed concrete is that we are introducing compressive stress into a concrete beam. Okay, so first the precast, so first we are having a precast concrete structures. Okay, to the precast, so imagine this is a precast concrete structures. Okay, this is one concrete structure. Okay, so you are introducing compressive stress. Compressive stress means what? This is a compressive stress. Okay, you are introducing a compressive stress into this precast unit. Okay, and this due to this compressive force, what will happen? The beam will bend in this direction. Okay, so during the manufacturing process, you will be introducing a compressive stress into the concrete beam, and due to the compressive force, the beam will be bent in the this direction. Okay, now this structure will be used for the construction purpose. So what is happening when a load is applied to such a structure? Okay, this is a structure right now. When the load is applied, maybe it is a UDL, maybe it is a point load, what will happen? Definitely deflection occurs. Okay, deflection always occurs in a downward direction. Okay, when load is applied, deflection occurs in a downward direction. Okay, so how this beam will deflect in a downward direction? Okay, so downward means how it will have, how the deflection will occur. It will, deflection will be occurring like this. Okay, are you getting my point? Level പൊന്തി നിൽക്കുന്ന സാധനത്തിന്റെ മുകളിൽ you are applying a force, so definitely what will happen, it will go down. The deflection occurs in a downward direction. Okay, so after application of the load, this is the deflected shape of the concrete structure. Okay, so you can see this shape is a stable shape. Okay, this shape will not fail. How is the failure occurring? Failure will occur when there is a downward deflection. Okay, when the beam is deflecting in a downward direction, the crack will occur and failure occurs. So this is how failure is occurring. Okay, suppose if the beam is like this, okay, during the service time, if the beam is in this position, will it fail? It won't fail. See, it won't fail. Okay, so that is the advantage of pre-stressed concrete. Okay, now I'll show you a video. Okay, so you will be thinking how this is possible. Okay, how practically it is possible. Okay, first question, that the first doubt you might be having is that how the compressive stress is introduced into this concrete. Okay, and how it is practically possible. Okay, so you will be having a difficulty to visualize this in a practical way. So for that I will show you one video. So understand this concept and see the video. So you can see the bridges over here. Okay, so see here. Okay, so normally our precious concrete is used for the transportation purpose. There you will be having a large amount of vehicle loads. Okay, it is very difficult compared to a building. Building, you can say only human loads, or you can say some machine load. But if you considering the bridges, railway bridges, all these things, load is very high. Okay, so even we are constructing the railway bridges over the sea links. Okay, so the load is very high. Okay, so what is happening is that while the load is passing, if you are using a normal concrete, the tension at the bottom portion will be very high, and due to this, failure may occur. Okay, the bottom portion tension will be very high, and it may lead to a failure. So this is not sufficient. Okay, so to overcome this, we are actually introducing pre-stressed concrete. Okay, pre-stressed concrete. So this is a pre-stressed concrete. You can see. Okay. So this is the arranged, or you can say the experimental setup or the laboratory setup of a pre-stressed concrete. Okay. So this is the mount of the pre-stressed concrete unit. Okay, like you are having mold in the laboratory. Okay, this you might have done in the concrete lab. We are having molds. Okay, so this is a mold of that beam. Okay, so you can see here at this bottom portion, tendons are attached here. Okay, bottom portion. Tendons means what? Tendons means it is a group of wires. Okay, tendons means they are a group of steel bars. Okay, they are a group of steel bars which is bonded together as a single unit. Okay, so tendons means it is a group of steel bars which is bonded together to act as a one unit. Okay, so this tendon, if you see the cross section of this tendon, it will be having some 8 or 10 steel bars. Okay, so see here. So the steel bars is provided at the bottom portion, and you can see it is anchored here. Both portion it is anchored here. After that, you will be pouring concrete. Okay. So you can see. Okay. So you have poured concrete over it. So here, what is happening? The tensile force is applied. That means this tendon is anchored over here. Okay, this tendon has been stretched, and it is anchored at the both sides. Okay. Now see this. Okay, now we are cutting it. Okay, now we are cutting it. So what will happen? Eventually a compressive force will be introduced into the concrete. So this is how the compressive force is introduced. Okay, so something like for example, if I'm telling a rubber band. Okay, so if you stretch a rubber band and you release the rubber band, what will happen? A compressive the rubber band will try to regain its original position. That is, it will try to compress, it will take its original position. The same thing is happening here also. Okay, so prior, what is happening? You can see in this video that this tendon is anchored over here. The tendon is stretched and it is anchored over here. Okay, so once the concrete beam is set, you are cutting it. Okay, so an compressive stress will be introduced into the concrete beam. Okay, okay. And this is the practical applications where you are using the precast structures. Okay, and this precast, see this bridges. Okay, so this bridges, it is actually made up of this pre-stressed concrete units. Okay, so at the somewhere at the factories or laboratories, you will be constructing such precast pre-stressed concrete units, and you will transport it to the site, and at the site you will assemble it. Okay, at the site you will assemble it. Okay, so normally, if you have ever seen any bridge construction, this you might have seen. Okay, you will be using pre-stressed concrete structures. Okay, if anywhere, if you are seeing any bridge construction, just go and watch. Okay, the next is pre-tension concrete. Okay, so pre-tension and post-tension. Pre-tension means what? You are applying tension before the concrete is poured. Okay, so here what is happening? You are applying tension after the concrete is forced. In the post tension in concrete, you are applying tensile force after the concrete is set. So here you can see. Okay, so see in this figure. So this is a concrete beam. Okay, so this is a concrete beam. Okay, so this is the tendons that is provided at the bottom portion, and it is anchored over the sides. Okay, the sides, the tendons are anchored. Okay, now you can see the tensile force is applied to the tendons. Sorry, this is pre-stress. Okay, this is pre-stress concrete. Okay, right now what you're seeing is pre-stress. Okay, now this is a post-tensioning concrete. Okay, this is a post-tensioning concrete. Okay, post means tensile force is applied after the concrete has been set. Okay, so this is a structure. Okay, you can see this a concrete beam is already cast over here, and you are provided a duct in the bottom side. Okay, you will provide a duct in the bottom side. Okay, now what will happen? Tendons are inserted into this ducts. Okay, tendons are inserted into this ducts. It is anchored over the sides. Now tensile force is applied. You are having the machineries so that the tendons will be stretched. Okay, if you are stretching, tensile force is applied. Okay, so tensile force is applied over this tendons. Okay, so did you get the difference between a pre-stressed and post-tension concrete? Okay, so pre-tension means first you are casting the concrete. Okay, first you will be casting the concrete beam, and while casting itself, you will leave a duct inside. Okay, while casting itself, you will leave a duct inside. Okay, now after the concrete has been set, you will insert a duct. You will insert the tendons into it. Okay, and next process, the tendons will be anchored. You can see in this figure, the tendons, it will be anchored. Now what will happen? You are stretching the tendons. That means you are applying tensile force. Okay, and eventually you will after that you will cut the both sides, both the tendons will be cut. Okay, so this is post tension concrete units. Okay, so both pre-stress and post tensions are very important, and they are gaining importance in the they are gaining importance in the construction industry, because when you are going to the abroad countries, you can see they will be using more pre-stressed and post-tension structures. Why? Because there the tension, so there the load is very high, because they are always going for a high-rise buildings. Okay, so this can be used for the high-rise buildings. Okay, transportation purpose. Okay, when you are going for the multi-lanes bypass roads. Okay, pre-stress and post-stress are very important because only this structure can carry this much of load. Okay, normal RCC fails under those conditions. Okay, so in that time you have to go for pre-stress structures, pre-stress and post-stress structures. Okay, okay. Now I will show you another video how a precast concrete structures are constructed in a mass way. How now that you have seen the construction of one precast unit. Okay, now just see, this is how it is done in a real way. Okay, so this is a concrete, this is a mold. First you will keep the tendons over it. Okay, okay, so these are the arrangement that is provided to attain the proper shapes. Okay, to attain the proper shapes. So can you see? So see, okay, so see the tendons are provided. So this is maybe this is a concrete beam of some 500 mm or something like that. Okay, so they have provided 1 2 3 4 5 tendons. Okay, they have provided five tendons over the bottom side, and see they have anchored it over the side, and they are stretching it. That means they are applying tension. Okay, they are stretching it. See, they are stretching the tendons. After that they are pouring concrete. Okay, after that the concrete is poured. Okay, definitely leveling, all those things you have to do. Okay, now that they are cutting the tendons. Okay, the tendons are cut. So what will happen? Okay, these tendons, they were actually in a stressed position, right? They were in a stretch position. Okay, so immediately when you cut this tendons, what will happen? It will try to regain its original position. That means it will be applying a compressive force on these units. Okay, so imagine like a rubber band. When you stretch the rubber band and when you release it, what will happen? Or when you stretch a rubber band and you cut in the middle. Okay, but immediately one portion of the rubber band will strike on your hands. Okay, the same way, see when you cut it, that compressive forces will be applied. So see, this is a pre-stressed concrete structures. Okay, so like that you will be casting pre-stressed concrete units, and this units will be taken to the sides. Okay, like this. Okay, so this is how this units will be taken to the site. At the site, you will assemble it and you will combine it using the steel wires. Okay, you can see all the ducts over here, right? Okay, okay. So this is what we are normally doing in a site during a bridge construction. Okay, so I think it's pretty clear now what you mean by a pre-stressed concrete and a post-up. Second video is the how you are making pre-stressed concrete units. First video is very important. Actually, I will give you the link of this video. If you are having doubts, you can check it. Okay, while studying the theory portions, just see this video once again. Okay, this video, not the second video, this video. Okay, so this video tells you explains you exactly how the pre-stressed and post-tension is working. Okay, so this second video shows you the manufacturing process. Okay, at the big factories, how will you manufacture these pre-stressed structures. Okay, so this if you ever see like if there is any construction, you should go and watch. Okay, coming to the next, we'll continue with our theory now. Okay. So I think now that you have understood what you mean by pre-stress and post-tension structures, now you will go to the technical details. That is, what are the stresses that is developed? That is the forces that is acting on a pre-stressed concrete. Okay, coming to the principle of pre-stressing. Okay, so pre-stressing is a method. Okay. So pre-stressing is a method in which compressive force is applied to the reinforced concrete section. Okay, just now we have seen the effect of pre-stressing is to reduce the tensile stress in the section to the point till the tensile stress is below the cracking stress. Thus, the concrete does not crack. Okay, so our prior aim or our major aim of the pre-stressed concrete is to reduce the tensile stress of a section. Okay, so the initial of this video, the starting of the video, we have shown you the bottom portion tensile stress will be very more. Okay, so our aim is to reduce the tensile stress and you have to lower it below the cracking stress. Okay, you have to keep the tensile stress below the cracking stress. Okay, why? To avoid the cracks. Okay, if the tensile stress is below the cracking stress, there won't be any crack. What do you mean by cracking stress? Cracking stress is a stress at which crack is formed. Okay, for example, if I'm telling just an example. Okay, 5 Newton per mm square is a cracking stress. Okay, so at 5 Newton per mm square, cracks are occurring. Okay, so our aim is to keep the tensile stress of the pre-stressed concrete structures below the 5 Newton per mm square. Okay, that is our tensile stress should be something like 1 or 2. That means we are safe. Okay, if this is 1, 2, 3, 4, 5 means what will happen? The section will break. Okay, so you have to keep the tensile stress below the cracking stress. So that is the one of the important principle of pre-stressing. It is then possible to treat the concrete as an elastic material. Okay, so we are treating here it as an elastic material. Concrete can be visualized to have two compressive force, internal pre-stressing force and external forces. Okay, so in such a pre-stressed concrete, in such a pre-stressed unit, you will be having two forces, that is internal pre-stressing force and the stress which is developed with the external force. Okay, so these forces should be counteracted. Okay, now if you are taking a cross section of a pre-stressed structure, okay, so first one is this, you can see. Okay, the stress diagram due to pre-stressing force. Okay, so you can see, you might have seen this process, there is a lot of application of forces coming. Yeah, compressive forces are installed. First you are applying the tensile force. Okay, after that a compressive force is introduced into the concrete sections. Okay, so first figure is, it shows the pre-stressing force, stress due to the pre-stressing force. Okay, so it is having a rectangular shape. Okay, so that is the one stress that is developing in the section. Okay, that is one of the stress that is developing in the section, that is due to pre-stressing force. Okay, pre-stressing means what? First you are applying stress on the steel bars. Okay, you are applying stress on the steel bar. First you are stretching it, after that you are releasing it. Okay, so that is pre-stressing force. Okay, so because of that pre-stressing force, because of that pre-stressing, a stress will be introduced into the force. Sorry. Because of that pre-stressing, a stress will be introduced in the concrete section. Okay, I will tell it once again. Because of the pre-stressing, a stress will be introduced in the concrete section. Okay, so that's the first one. That is the stress due to pre-stressing force. Second one is due to the applied load. Okay, so applied load means that is there will be live load will be there. Okay, live load is applied load plus you have to consider the dead load also. Okay, so this is the stress due to dead load. This is a stress due to dead load, and this is a stress diagram due to live load. Okay, so these stresses are developing in a concrete section during pre-stressing. Okay, so this is very important. You have to study this diagram. At the same time, you have to study the equations also. Okay, so this is a resultant stress diagram. Okay, this is a resultant stress diagram. Again, the resultant stress diagram we can see bottom portion there is no tension. So that is our prior aim, right? In the starting we have said our aim is to keep the tensile stress below the cracking stress. So here we have achieved it. The bottom portion you are not having any stress. So there is a compression over the top side. Okay, anyway we can deal it. Okay, so see this. Now, okay, so this is the explanation of pre-stressing and post-tensioning. So you have to study the both. Okay. So in the second video you have seen, right, pre-stressing, how they are casting pre-stressed units. So this is the figure of it. Okay, this is the figure of the second video that you have seen, that is the casting of pre-stressed units. This is post-tensioning. Okay, post-tensioning. So this is a tendons. Okay, this is a tendons. Okay, tendons means what? Tendons means they are a group of steel bars which is tied together, and it will be covered with some it will be covered with some protective layer to act as a one unit. Okay, so see here, 1 2 3 4 5 6 3, I think there are 10 numbers, more than 10 numbers of steel bars are tied together and they are covered with a protective layer. Okay, so this will act as one unit. So this is called as a tendon. Okay, see this. See this figure. Okay, so this figure shows you pre-stressed units. Okay, can you see the PPT? Okay. Okay, so right now what you're seeing, this is a pre-stressed units. Okay, that is being lifted and that is being taken to the site for the construction. Now coming to the advantages. Okay, advantages of this structure over normal RCC. First of all, it takes the full advantage of a high strength concrete and a high strength steel. Okay, that means it is completely utilizing a high strength concrete and a high strength steel. You need very less materials. Okay, comparatively, if you see the materials used will be very less, then it will be smaller and lighter structure. So you can see from this figure. See this figure. Okay, so here what is happening? This is smaller and a lighter structure compared to the normal RCC. You can see that here materials used is very less, and also sections are very thin. No cracks will be formed. Okay, so that is a one big advantage we can say. There will not be any cracks. use the entire section to resist the load. Okay, so here what is happening, the entire unit is resisting the load. Okay, next one is it is corrosion resistance. Okay, then it can be used for the water tanks and nuclear plants. Okay, this can be used for the water tanks and nuclear plants, and this is very effective in controlling deflections, and they also give a shear resistance. Okay, they also give a better shear resistance. So these are the advantages of this pre-stress unit. Okay, okay, this you might have seen, this is actually called as a leafy fish belly structure. Okay, this is fish belly structure that is normally used in the bridge construction. Disadvantages. So every material it will be having its advantage and disadvantage. So what is the disadvantages? Okay, here the disadvantages are, here you cannot use normal quality materials. You have to use high quality materials. That is prior to the construction of pre-stressed units, you have to check the quality of the materials. Okay, so you need a very high quality materials. Okay, second one is its complex is very technically. Okay, that means you have to calculate a lot of loads here. That means live loads will be there, dead loads will be there, pre-stressing force will be there. Okay, so technically there is a lot of calculations. Next is it is very expensive. The construction process is, the manufacturing process is very expensive. Second one is it cannot be recycled. Okay, it cannot be recycled. So normal RCC structure after 50 years or after 20 years, if you demolish the structures, you can take the steels out of it. Okay, you can demolish and you can take the steels, or you can take the essential materials. You can take the congregate parts, concrete aggregates for concrete aggregates, and you can use it for some other purpose. But here it is very difficult to recycle the units, pre-stressed units, where it is applied. It is applied to the bridges, slabs of the building, water tanks, concrete piles. Water tank in the sense, not the normal water tanks. We will be going for a high water tank, that high capacity water tank. Then concrete piles, tin shell structures, offshore platforms, nuclear power plants, repair and rehabilitation centers. Okay, so these are the areas which requires a lot of loads. Okay. Um, Next is, say if you want to see a figure, this is the figure. Okay, this is the arrangement of a pre-stressed concrete beam. Okay, so you can see that tendons are applied, they are stressed, how they are stretched. So coming to the next one. Okay, so next is the materials that is used for the pre-stressed concrete. Okay, so normally, as we have already told, we cannot use a normal quality materials. You have to use high strength cement and high HYSD steel bars. Okay, high HYSD steel bar. That means high strength steel bars should be used. Okay, The cement that you're using should be of very good quality and of very higher grade. At the same time, steel also should be HYST with a good grade. Next, you can see another see this figure. So steel, we can go for either see in this first figure they have used the plain bars. So this is a plain bars. Okay, but nowadays we are using deformed bars. You can see this is a deformed bars. So deformed bars means actually it give you more resistance. Okay, you can use deformed bars. So if you're using deformed bars, the bone stress will be very more, and also slip won't be less. So this is how it is anchored. You can see in this figure the tendons are anchored over here. Okay. Okay. Next, another important thing is, so these are the materials. Okay, materials are also very important. What are the materials is used for the pre-stressed concrete? Next is, we are facing certain losses during the pre-stress. Okay. Okay. Okay, this is very important. You have to study this also. Pre-stressing steel. Okay. So I'll just quickly tell it. Prestressing steel means generally you will be using an alloy of iron, carbon, manganese, and other optional materials. Okay. So why you are using this means it will be giving you a greater shear capacity, and temperature and shrinkage will be very less. Shrinkage stresses will be very less, and it will also having a good flexural capacity. Okay, so normally the pre-stressing steel that you will be using, it will be an alloy of iron, carbon, and manganese. Okay, so anyway you will be using high strength steel. Normal steel cannot, mild steel cannot be used. Only high strength steel can be used. Okay, so that will be an alloy of iron, carbon, and manganese. Okay, now you can use wires. Okay, so three units are there. First one is, okay, I think already time now. Okay, we can continue in the next class. Please post your names to mark the attendance. Okay, just so in case next hour I'm thinking to start the problem. In case if there is any message, so in case if there is any doubt, just let me know. Okay, I think the concept is clear now.